In this episode of the .NET 5 REST API tutorial, we will start our path towards getting our API deployed to a production environment. We will learn about the traditional challenges involved in getting the API bits deployed outside of our developer box, how Docker can help us address these challenges, and how to turn our existing API into a Docker container. Today you will learn the challenges of deployment, how Docker works and why you should use it, how to turn your REST API into a Docker image, and how to run your REST API as a Docker container. So the way that things are at this point, you know that we do have a REST API up and running in our local box, and there's also a MongoDB database running next to it as a Docker container. But now we need to figure out how we're going to share this REST API with the world, right? Either how to share the REST API with people inside of our local intranet, or how to share the REST API with the world, perhaps in the public internet. And that place where we're going to share things is what we're going to call the production environment. This production environment could be anything from some server running in your building or in your house, or it could also be some server running somewhere in the internet, right? But for all our cases, this is the production environment. This is the place where people will be able to access the REST API without having to get access to your local box, your developer box. And one of the first things to think about when we want to pick this server for production is the operating system. So we will need to figure out, we need to find the right server with the correct version of the operating system that our REST API is able to support. So in the case of a REST API, it's not really that much of a big deal because .NET 5 is cross-platform. So what we have built so far, it should be able to run in a bunch of operating systems. But still, we need to settle on some operating systems. So if we say that we're going to be running this on Linux, then we need to go ahead and make sure that we have Linux available, the correct distribution and version of Linux available in that production environment. Then we also know that we do need the .NET 5 runtime to be able to run a REST API. A REST API is built on .NET 5, therefore we do need the .NET 5 runtime, and all the corresponding files of it, they need to be placed in the right place in that production box. On top of that, our app may have a bunch of dependencies, like the MongoDB driver that we've been using to talk to MongoDB. So like that, it may have a bunch of dependencies that they also need to be placed into the production box so that finally our REST API can be placed alongside all of these other components, and it can run happily. So it is at that point that we can consider that we have all the files necessary for the REST API to be running in production. But then also we have to consider that we also have database requirements, right? So we have a database that we need to place somewhere in this production environment, and it will have its own requirements in terms of operating system and dependencies that MongoDB may have, the MongoDB engine, all these things that we need to run the database in production. So that by itself presents another set of requirements. So as we think about all of these things that we need to happen to get our production up and running, so we need to think about a few challenges, right? So the first thing is going to be preparing a box. So what you really want is to make sure that whatever box we use for production has everything that we have had so far in our developer box, right? And then, but you also have to think about, so are we going to pick a physical machine? Are we going to pick a virtual machine, where virtual machine is really just a virtualized version of operating system running on top of some other physical machine? So, and regardless if it is physical machine, virtual machine, we need to figure out, well, where are we going to get this machine from? Where are we going to host it? Who is going to be taking care of this machine? A bunch of questions just regarding this machine. But also we need to figure out, okay, so is it going to be Linux or Windows? Who's going to put the right version of the OS in there? Who's going to make sure that it has the right set of patches? And who's going to maintain this? Really, somebody needs to take care of these things. Then also, how are we going to take the files to the production machine, right? So we have all these files in their box, and somehow they need to land in production. How are we going to do this? Are we going to be using perhaps some FTP protocol to be able to talk to and send the files to production machine? Are we going to put the files in some USB or pen drive and then just copy them using it into the production machine? Are we going to send the files to some person from operations via perhaps some email, and then that person will place the files in there? How are we going to make this happen? The files need to get there one way or another. What happens, I mean, in this case, we're thinking of placing, let's say, the database server just next to the REST API. If you're going to do that, how are we going to make sure that all of the dependencies of the database and the dependencies of the REST API have the right versions, even when we're placing everything in the same machine, right? So there could be version mismatch between the things that are needed in the MongoDB database and the things that are needed in the REST API, right? Starting from the operating system. How do we make sure that all the dependencies are the right version for both of them? And if they cannot be, we have to figure out, okay, so perhaps we need to split this REST API into one machine and the database server into another machine, which would not be that uncommon. But we have to think about all these things. Also, what if we eventually decide to move to a new version of .NET, right? So let's say .NET 6 is out. We want to move to .NET 6. What does that mean? Do we have to bring in a brand new set of servers, physical or virtual, that are already enabled for .NET 6? Do we want to just update the version of .NET in the existing server, and then somehow make sure that the app does not break by making that change? How are we going to make that happen? Also, how do we start REST API on the machine? Because it is not just about copying the files in there, right? So somehow we need to start the .NET app into the server, and somebody has to do it, right? So we'll have to bring in some sort of automation, some sort of scripting. Something needs to happen in that machine to be able to start REST API, and not just start it, but start it fast. We want to make sure that as soon as we put the bits in there, the application just starts quickly so that it can start serving our users. And finally, what if one instance of the app is not enough? So what if we start having so many users and just having one web server for a REST API is not enough? And now we need to bring in yet another, let's say VM, a virtual machine for a REST API, and then another one, and then another one. So who's going to take care of provisioning all these VMs for us? And what about the database? What if we actually need multiple copies of the database server to be able to handle the load? So how is all of this going to happen? So do we need to think about all these challenges? Do we need to deal with all of this, or is there a better way? So luckily, here's where Docker can help us. So now let's go back to our local box. So yeah, so we have our local box, has REST API and the database currently, and we need to get to production. But now, instead of starting to worry about how to copy all the things into production and how to make sure that production has the right things already in place, we can start using this thing called a Dockerfile. So a Dockerfile is kind of a template of all the things that are needed by your, in this case, a REST API to get it deployed into production. So in the Dockerfile, you will declare things like the operating system that we're going to need. So you're going to say, I run in this specific version on this specific distribution of Linux, let's say, or in this specific version of Windows. So it is already declared in that file, and so you're saying as long as that version is available in the production machine, I am going to run just fine. And not only that, you can say, well, I actually need the version 5.0 of the .NET or ASP.NET Core runtime available in there. And by doing this, as long as I have all the dependencies of the .NET Core runtime, I am able to run my REST API, right? So you can declare the runtime that you're going to be running on. You can also declare, or you can prepare all the dependencies that are needed for your app, right? Like the MongoDB driver and any other DLLs or any other dependencies that need to be present in there. You can specify how to place the files that you want to put in that production environment. You can say where exactly you want to put them. And you can also tell it exactly how to get started or how to start that REST API. So that scripting that is needed to say how to start it, it can also be set in this Dockerfile. So just by using the Dockerfile, you're already handling a lot of the challenges that we were talking before, because this Dockerfile is clearly declaring exactly how the environment needs to be built for your REST API to run properly. And so, but then it is not enough to just have this Dockerfile. So now that you have Dockerfile, what you're going to do is use this thing called the Docker engine to actually prepare what we call a Docker image. So what happens here is that the Docker engine, which is just a process running in your box, the Docker engine is going to take that Docker file and it's going to tag it and build what we call a Docker image. Tagging is really just kind of a synonym for creating a version for your image. So you're going to set a version on that image and then you're going to build it. So building a Docker image means reading that Docker file line by line and executing all those instructions to prepare the environment where your REST API is going to run. And that goes all the way back to ensuring that all the exact dependencies are in place, put the files in the right location, and starting the app, right? So all of that is encapsulated in that Docker image. But then once you have the Docker image, it is not enough to just have it running in your machine, right? So what you really want is to make it available in production. So how do you take it from your box into production? So enter the container registry. The container registry is a place that could be anywhere, going from some server in your internet to somewhere in the cloud. It is the place where you can place your Docker image, you can push your Docker image so that it eventually becomes available for your production environment. So this container registry, I mean, you don't necessarily have to be the one that pushes the Docker images in there. There may be some other images already available in container registry. So for instance, in the case of MongoDB, we've been using an instance, the Docker image of MongoDB since a few episodes back. We did not actually create that image. The image was already there. And that image is actually available in a specific container registry called Dockerhub. So Dockerhub is a public registry where many vendors place their Docker images for public consumption. But just like there's a Dockerhub, there's also other private container registries like Azure Container Registry, Google Container Registry, Amazon ECR, I think is the name. There's also these days GitHub Container Registry. So there's a bunch of versions of this available. But all of them are able to operate with your Docker images in really the same way. So once you have pushed your Docker image into the container registry, then you're able to have your production box, either physical box, virtual machine, whatever it is able to pull your Docker image into it. And by pulling it and executing that image, it turns into what we call a Docker container. So the Docker container becomes kind of a living version, an executable or running version of your Docker image. So the Docker container, just has has all the files and all the dependencies that have been declared in the Docker file and executes the REST API the way that you have declared it in the Docker file. And just like how we stand up the Docker container for the REST API, we can stand up the Docker container for our MongoDB Docker image. And then, of course, these containers can talk to each other. And all of this magic, I mean, it only works just because you also have the Docker engine, the same Docker engine that you have in your box, you will have it available in the production environment. So here, as long as you have the Docker engine available in whichever machine you want to go ahead and run your Docker image, then your Docker image is guaranteed to be able to run as a Docker container in that environment. The only thing that you need is a Docker engine, and that brings a lot of benefits along the way. The other thing is that you not only can run one instance of your Docker container, you can actually run multiple instances of your Docker container. So as you need to scale up more and more, perhaps because you have too many users, then you can just start spinning up more and more copies of that Docker image into Docker containers in production without having to incur into a lot of hassles to be able to provision more and more environments. So lots of benefits about Docker really here, and starting with efficient resource usage. So as opposed to the case of having to stand up new virtual machines or new physical servers, you don't have to really incur into a lot of new resources. Spinning up a new Docker image does not take a lot of RAM, does not take a lot of disk space, because there's a lot of caching happening in there by this thing called layers in Docker. So a lot of caching, memory is only going to increase in terms of what exactly is needed for your image, for your service, for your REST API. And so you can really fit much more instances of your REST API, and in this case also of your database, many more instances in the same production box as you could before just fit one instance of your REST API or your database or your MongoDB container or your MongoDB database in the same production box, right? So you can fit much more by using containers. There's also fast start because the Docker engine is able to cache all these layers only the very first time that it needs to pull down the Docker image. It will do that with all the layers, but from there on it will be able to just pull only the layers that have changed, and so that allows it to really start very fast. And so you don't have to boot up an entire operating system just to boot your app, right? So the operating system is already in place. You just need to start your app, and Docker is able to do that very, very fast. There's also isolation. If each of these containers is running in a completely isolated way, so it doesn't matter what's going on in the actual production host machine or what's happening with any other containers running in the box, each of the containers are running in isolation, and so from their point of view, they are the only thing happening at that point in time in that environment. So that gives you a lot of benefits from that side. And then also you can think of these containers as being able to run anywhere, and because like I said, as long as there's a Docker engine running in your production machine, you are guaranteed to be able to run your Docker container in there. So lots of portability. And finally, scalability, like I mentioned, in the same space where before you will be able to run just one instance of your REST API, like in the case of virtual machine. Now you can actually run multiple instances of your Docker container with using a much less amount of resources in there. So you can really scale significantly by using Docker containers. Let's see now what we need to do to containerize or Dockerize our REST API. To create the Docker image for our REST API, the first thing we need to do is create the corresponding Dockerfile. However, before doing that, and to keep things simple, we will update our REST API so that it no longer performs HTTPS redirection and allows the use of the HTTP address only. The use of HTTPS from here on is a topic out of the scope of this tutorial. So what does this mean? If you remember, we do have two URLs configured for our REST API. And those are configured in our launch settings file under properties, launch settings.json, application URL. We do have HTTPS localhost 5001 and HTTP localhost 5000. And the way that things are configured right now, if anybody tries to access HTTP localhost 5000, they will get redirected into HTTPS localhost 5001. If you want to test this, what you can do is just launch the app. So I'll do F5 here. And I'll open Postman. And normally we will go to HTTPS localhost 5001, but I'll change this into HTTP localhost 5000. And in this case, I'll actually open the Postman console down here to see what's happening behind the scenes. And I'll do send to query for items. The query succeeded. But then if you see, there are two calls in here. The first one for HTTP localhost 5000/items actually returned a 307 code, which means a redirect. And then that was followed by a call to HTTPS localhost 5001/items. So that's the redirect that has been configured right now, and is what we want to change for the Docker case at least. So how do we change this? Going back to VS Code, and I'll just stop the app and close this for now. This is configured in startup.cs. Under the configure method, we have this line here, app that use HTTPS redirection. So it turns to be that when you run inside the Docker file, inside the Docker container, the ASP.NET environment switches from development into production. And this is what we can use to put a conditional on this line. So what we can say is if m.isDevelopment, then we will allow the HTTPS redirection, but otherwise we will not allow it. That's the only change that we're going to make here. We will see how this works actually when we have the Docker container ready to go. At this point, I'll just close this. And now we actually want to generate, or actually to create this Docker file. So there's two ways to create a Docker file. Either you can create it manually or you can generate it. For this tutorial, and to speed things up, we will generate it. So to generate a Docker file, what I would recommend if you're in Visual Studio Code is to use the Docker extension for Visual Studio Code. And that you can find if you go to the extensions hub. You can just type Docker here. And then you will go ahead and install the extension. And now I'll close this. And now what you can do is just say view command palette, and then you can type Docker, add Docker files to workspace is the first option there. So now you get to pick the platform of the Docker image we're going to create. In our case will be .NET ASP.NET Core. Then you got to pick the operating system of the container. In our case, it's going to be Linux, just because it's the most popular option most of the time. And then you got to pick the port that you're going to be listening in within that container. In our case, that's going to be port 80. And finally, if you want to generate a Docker Compose file, we will not use this in this tutorial. So just hit no. And now if you go to our Explorer here, you're going to see there's a couple of new files. We have the Docker file and the Docker ignore file. So let's start by looking at the Docker file. In the Docker file, each line that you can see here represents one set of instructions that are going to be applied as the Docker image, our Docker image is going to be built. And each of these lines will also generate what we call a layer that represents the changes that are happening from one line to the next line. And that's what helps a lot in terms of caching of steps as we do subsequent builds of this Docker image. So the first time when we build it, it will take time, and then subsequent times it's going to be much faster. Now let's go line by line here to understand what's going on. So the first thing that's happening is that we're saying that we will be building out our image based on the .NET ASP.NET image, specifically version 5.0, right? So that's a way that you start by saying where do you want to go from. By specifying .NET ASP.NET, you are guaranteed to be building your image based on a working ASP.NET environment. In this case, a 5.0 environment that has all the dependencies that are needed to run an ASP.NET app. And not just that, the ASP.NET image has at the same time has been built based on the correct OS, based on where you're running your image on. In our case, since we're going to be running it in a Linux machine, that will include all the dependencies to run an ASP.NET Core app or the .NET 5 app in Linux. Now we're also saying this is 5.0 as base. This means that this is going to be our first stage of building the container. This is a good segue into the concept of multi-stage builds, which is what's enabled here. This means that there will be more than one stage in the build process, and in each stage you can specify a different set of instructions that may have nothing to do with the instructions executed in some other stage. So for instance, here we're saying, so this is the first stage, and we'll call it base. And in this stage, we'll go from .NET ASP.NET, which is the runtime image for ASP.NET 5. Work there is going to be /app, means everything that happens after this will happen in the app directory. And then that we expose port 80. This line actually does not mean much. It's just a kind of a documentation field. The way that you expose a port is a bit different actually, but there's a convention to specify the port that the app is listening in. Now that temporarily finishes that first stage, and in the next line, in line 5, we're going into our next stage that we're calling build. And the interesting part about this stage is that it comes from another base image. If you notice, this is coming from .NET SDK. So .NET SDK 5.0, as opposed to .NET ASP.NET. So .NET SDK is the image that has all the build tools and all the libraries, everything that's needed to build an .NET 5 app, which is not the same that you need to just run a .NET 5 app, right? So this, whatever is coming in this ACK image is potentially much bigger. There's a much more files, compilers, and stuff in there that are needed for building the container, but not needed for just running it. So that means that your final image that's going to go actually from the base image is potentially going to be much smaller than the image that you're going to use to build your container. So we start with this stage. In this case, the work there is going to be /src. So that's where we're going to place any files from here on. And that's exactly what we're doing in the next line. We're saying, okay, so let's copy the catalog.csproc file, the one that defines our project, into the root of the current location. And then we will run a .NET restore on that project. So that brings in all the NuGet packages that are needed. Then we say, okay, so we have restored all the packages. Now copy every other file that's needed for our app. So that includes all the files that you can see on the left side, except for a few exceptions, but most of the files are included here. And we'll talk about that in a moment. And then there's this line here that's actually not that much needed, because as you can see, it's pretty much the same as line 6. So we will actually delete this in a moment. And then we go into the actual build process where we say, hey, go ahead and perform a .NET build on catalog.csproc. We're modifying the current configuration to not be debug anymore. We want a release version of the app to optimize it for the production environment. And the results of that build should go into the /app/build directory. So currently that finishes our build stage. So it's this section here. And then we're switching to yet another stage that we're calling it publish. In the publish stage, what we're saying is actually we're going to go from the build stage. So notice now we're going from build, is the stage that we just created. And we will go from there and name it as publish and just execute the .NET publish command with similar set of parameters than the previous one, just changing the output directory. So .NET publish, what it does is it creates a new folder, in this case called publish, with all the files that are needed in the right shape to just execute the app. Now at this point, I like to point out that I find a few of these lines a little bit redundant. So we could simplify things a little bit here. So I don't think we need to separate both a build and a publish stage. So I'm going to make a couple of changes here. So I'm going to actually remove this workdir source line, because we already have this in line 6. So I'm going to remove that. And I'm going to also remove .NET build, just because .NET publish also performs .NET build for us. So there's no need for two separate lines. And I'm actually going to completely remove the publish stage, because our build stage should be good enough for what we need here. So now we just have one stage called build, well, one second stage called build, that will end up by running .NET publish, and all the files that we need should end up being in app publish. Now in line 12, we go back to our initial base stage, build stage, and we're going to be calling it as final, right? So now we're pretty much finishing what's going on here. So we switch again to the app directory, and then what we're saying is, okay, so now let's copy from the publish build stage, which in our case is no longer there. We actually opted for build. So I'm going to actually copy this and change it into build. So from the build stage, go ahead and copy whatever is in the app/publish directory, the one that will replace all the files, copy all of that into the current directory, which will be /app. And finally, we'll define the entry point for our app. So this is how we define how to start our REST API. And in our case, that will be just by executing the .NET command with the catalog.dll file. That's all that's needed to start our REST API. With this Dockerfile, we're pretty much ready to build our image. But before doing that, what I wanted to do is just show you about the .dockerignore file. So this dockerignore file, what it does is it defines a series of files and directories that you want to exclude from the Docker image. So there may be one or more files that you don't want to include in the Docker image because it makes no sense. For instance, the stuff that we have under .vs code is really only useful for development purposes, but it means it makes no sense to include that into the Docker image. So for instance, this line here specifies, hey, just go ahead and exclude everything under /.vs code. And the same thing for a bunch of other files and directories. So a good file to not forget to keep in mind, otherwise your image will end up being bigger than necessary. So with that, we should be ready to start building our image. So what I'm going to do is just open a new terminal. And to build the image, what you do is just use the Docker CLI. So what we're going to say is Docker build. Then you have to specify a tag, the name for the image and a tag for it. So that you do via the -t modifier, and then we will give it a name. The name will be catalog, and then you give it a tag, which in our case, let's say is going to be v1. And finally, you specify the directory from which you're going to execute the command. In our case, that's going to be the current directory, which is specified by the dot. So I'll hit enter, and that's going to go ahead and build the image. So first thing it needs to do is go ahead and download any of the base images. In our case, that would be the .NET ASP.NET image, the runtime image. So we'll go ahead and do that. And then for the second layer, for the second build stage, it needs to pull in the .NET SDK 5.0 SDK 5.0 image, which may take a little bit more because it's bigger. And then it proceeds to perform the actual build process within the image. So Docker restore, and the actual publish, and then all the other steps that end up creating that image. So at this point, we have an image ready. And like I said, each of the lines, going back to Dockerfile, each of the lines here represents one layer that maps to each of the steps that you see here. So it says step, a bunch of steps here. So step 1 of 13, 2 of 13, 3 of 13, each of these will correspond to each of the lines that you can see on the Docker file. So these are the layers that will be cached from here on, so that you don't have to do them again. So in our case, if we don't make any change, if I just try to do docker build -t, the same command again, I hit enter, really mostly nothing happens because everything is cached. So only if you make some changes, then some of these layers may need to be executed again. Now, one thing to remember is that this is not the only container that we need for our REST API. We also have the MongoDB container, which is the one that acts as our database server, right? And which is the one that has our database. So we need to make sure that our new container for the REST API is able to talk to the MongoDB container. And the way to do that, at least in the local box, is by setting up what we call a Docker network and having both containers join that Docker network. So how do we deal with this network? To create a network, the only thing that you have to do is just say Docker network create, and you just give it a name. So we will say net5 tutorial, and that creates a network. If you want to see the existing networks, you can do Docker network ls, and you will see we have our net5 tutorial network already created. So now when we run our containers, we should take advantage of that network. So what I'm going to do is first make sure that I'm not running the MongoDB container yet. So I'll do docker ps. The MongoDB container is running right now, so I'm going to stop it. Docker stop Mongo. So that's stopped. And I'm going to run once again the same command that we've been using so far to run our container. Let me paste that here. Same command. But I'm going to add one modifier here that says network equals and the network name that you just specified. In this case, net5 tutorial. So that makes this container join that network. So I'll say Mongo, the name of the Docker image. So hit enter, and then the MongoDB container is running in that network. After doing that, we are ready to actually start running our catalog container, which, by the way, if you just do Docker images, you should be able to see our created image. As you can see, we do have catalog v1 ready to be executed, as well as the Docker images for the .NET SDK and the .NET ASP.NET runtime and Mongo. And so to run our Docker image, we're going to do something very similar to what we did with MongoDB. So we'll start by saying docker run. And then instead of doing -d for detach, we'll do -it for interactive. That allows us to keep our terminal connected to the Docker run process, just to see whichever logs are coming out of that container. And then we will do -rm, so that whenever we stop the container, it gets deleted, so we don't keep it hanging around. And now we specify the port. Similar as we did with MongoDB, now we have to specify which is the port that's going to be mapped from our local machine into the container. In our case, let's pick 8080. It doesn't have to be it. You can use any other valid port. And that needs to map to the internal port in the Docker image. Now, for ASP.NET and .NET 5 images, the base image itself, the ASP.NET runtime image, defines or overrides the port where the app executes, at least for HTTP. So that port is 80. So regardless of the fact that we've been using port 5000 for local development, when we base our Docker image in the ASP.NET Core runtime image, the port is overridden into 80. So you will have to specify 80. And if you don't want to use 80, there are ways to specify the port that you want to use in your Dockerfile. But in our case, port 80 will be just fine. Now we have to remember that in order for our app to connect to MongoDB, we have to specify a series of settings, right? So if you remember, when we go to app settings.json, we have this MongoDB settings section where we specify host, port, and user. And not only that, if we remember going back to settings, MongoDB settings, we specify host, port, user, and also password, which is coming from Secret Manager. So in this case, since we're trying to talk to MongoDB from within the container, we can no longer use just localhost to reach out to it. Okay, remember that each of the apps running inside of the container, both our REST API and the MongoDB, are running in an isolated way, and they can no longer resolve things by localhost. So for our REST API to talk to the MongoDB container, it has to do it via the name of the container of MongoDB. In our case, remember that we gave it the name of Mongo. So we have to override the host name to talk to Mongo. We don't have to touch app settings JSON file for this. What we can do is just take advantage of the configuration system of .NET 5 to be able to override the settings. So this MongoDB settings section can be totally overridden by environment variables, and that's what we're going to do now. So as long as we follow the convention, we should be able to make that happen. So I'm going to say -e. That's the way that you define an environment variable in Docker. And I'm going to say, I'm going to use MongoDB settings. So just copy that. And then I'll say :host. And that host is going to be Mongo, the name of the Mongo container. So that's how you can override this local host that's specified here. Now, the same way that we did that, we need to specify a password, because the password that we've been using so far is stored in the Secret Manager, and the Secret Manager is only being used for development purposes. It's only available in development environment. It is not available in production, and the Docker image, the Docker container, is really going to be running in a production environment. So how do we feed that password? Same thing that we did just now. We'll say MongoDB settings. Let's not forget to also add -e. MongoDB settings, password, and then we specify the actual password. Passbound word1, and that's it. And then let's not forget that we need to join also this container into the same network as the previous container, the Mongo container. So that's going to be network net5 tutorial. Make sure this is exactly the same network that you used before. And finally, the name of the container and the name of the image and the tag. So that will be catalog v1. And I think I may have a couple of mistakes here. So the first thing might be, let's see, yeah, so it should be --rm as opposed to -rm. And the next one would be, yeah, so this one should be equals as opposed to colon. And then I'll hit enter. So that has started our Docker container. And as you can see, our hosting environment has now changed from development to production. So production is the environment that will be reflected when you run the Docker image, as opposed to development anymore. So now let's see if things are working properly. We should be able to reach out to our REST API at port 8080. So let's open up Postman. And now let's just switch from port 5000 to port 8080. And let's see what happens. Send. And truth to be told, the API keeps working. But now, as you can see, we're hitting port 8080. So things are happening within the Docker container. Also, notice how we did not get a redirect anymore. So instead of getting a 307 like we did before, we got a 200 right away. So there's no more a redirect happening in there. We're just going via the HTTP endpoint. Now to keep things interesting, let's actually post one more item here via our post tab over here. And I'll do the same thing. I'll switch from HTTPS to HTTP, and then I'll do port 8080. And so let's say that we bring in back that antidote we used sometime in the past, and then I'll do price 15, and I'll hit send. And as you can see, I'll just close the console now. The antidote has been created. Now, really, the interesting part about Docker and Docker images is not just being able to create them, right? But also to be able to share them so that they can be used by either other persons or some other systems. So how could we share this Docker image that we have in our box now with somebody else, right? So just for the sake of this part of the tutorial, we'll do something very simple to see how this can happen. We're going to take advantage of a service called Docker Hub, which you can find. Let me open up the browser here. You can find at hub.docker.com. So this is the place that the creators of Docker offer so that people can publicly share their Docker images. So creating an account here is totally free. So feel free to try it out. So you have to come up with some Docker ID. It's kind of a username, an email, and a password, and then you can have your own account in Docker Hub. So how can I get my image published into Docker Hub? So let's go back to Visual Studio Code, and I'll stop my Docker container now by doing Ctrl+C. And the first thing that I'm going to do is actually logging in into Docker Hub. So once you have an account in there, you should be able to do a simple Docker login to be able to start pushing image in there. So what I'm going to do is just say Docker login. So this is going to ask me for my username. My case is Julio C. It will ask for my password. And now I'm logged in. So now, in order to get our currently existing image into Docker Hub, we just need to do a little bit of retagging to tell it where we want to place this image. So let's list our images once again. Docker images. And so here's our image, catalog B1. So what we want to do is just retag this in this way. So let's do Docker tag catalog B1. That's the current tag, catalog B1. And then our target tag is going to be starting with our username, my username in this case, Julio C, and then slash the name of the image in Docker Hub. When it gets to Docker Hub, it's actually going to be called a repository. And so that repository in our case is going to just be catalog. It doesn't have to be, you can choose, but I'd like to keep it just the same as we had before. So it's going to be Julio C / catalog B1. So hit enter. And like I said, this is just a tag. So if I do Docker images again, what you're going to find is now you have catalog B1 and Julio C / catalog B1. But if you notice the image ID and you look closely, you see that the ID that both of these images have is pretty much the same. So it's really, you can think of these tags as just pointers into one of the images. But with this retag, we are able to now actually push the image into Docker Hub. So what I'm going to do now is just say Docker push our newly retag image, catalog B1, hit enter. And this starts the process to upload not just our REST API Docker image, but all the layers that are composing this REST API needs to go into Docker Hub. So remember that our Docker image is actually based in the ASP.NET Core runtime image, and that one in turn is based in some distribution of Linux in this case. So all of those things need to go into Docker Hub so that anybody else can in the future just pull that image and start using it. So this may take a while because it's an upload task. All right, so the image finished uploading. And now if I go back to Docker Hub, what I'm going to do is actually sign in with my account here. And as you can see, I do have my image just uploaded a few seconds ago, Julio C/catalog. And here's the one tag that we have right now. So tag B1. So let's see. Now let's play the role of somebody that does not have this image in their system right now and that they want to use it. In that case, what they can do is either do a Docker pull or just run the image. So let me show you what I mean. So the image is now available in Docker Hub. So I go back to VS Code. And what I'm going to do is just completely remove the image that we have currently in our system. So let's do Docker images once again. And what we're going to do is just remove these two images so that it gets completely out of the system. And to do that, I'll do Docker RMI Julio C/catalog B1 and Docker RMI catalog B1. So now there should be no catalog image anymore in my system. As you see, I only have these three images right now. And so now, the other thing that I'm going to do is just do Docker logout to simulate somebody that actually has no access to my Docker registry. But since the image is public, they should be able to pull it. So in order to pull the image, you can either do the Docker pull operation, so Docker pull, or you can run it right away. So, and we can run it in the same way that we ran it before. So let me show you. It's going to be pretty much the same command line. I'm going to actually copy paste here. But now, instead of just saying catalog B1, what we can say is Julio C/catalog B1. So just keep in mind, so I am at this point, I am somebody that has never had access to the catalog REST API service. I have no access to the Dockerfile or anything about how we build this image. I just want to run it for the very first time. So I do this command line, I hit enter. It says, yeah, I cannot find this image locally. So we'll go ahead and actually pull it from Docker Hub and then run it. And as you can see, it is already running. And if I go back to Postman and I try to query for items again, I get my items from this Docker image. So that's how you can publish or push your Docker image into what we call a container registry, in this case Docker Hub, and then it is pulled back potentially in some other machine. That's how you can share it. So we may end up using some other form of Docker registry in future videos, but for now I just wanted to show you how you can do this sharing of Docker images across systems. And so yeah, so thanks a lot for watching this video. As always, if you liked what you saw here, please consider hitting that like button. And if you want to know of any new videos that I produce, consider also subscribing to the channel. And if there's anything else that you want to see in this channel, please feel free to leave me a comment down there. And yeah, thanks for watching, and I'll see you next time.